All right, let's get started. Good morning. My name's Jeff Meisner. I'm a program manager in Windows, and I work on Windows.Storage API and also WPD, Windows Portable Device Platform. We also have Ken Hardy up front. He's the program manager for AutoPlay, and he works in Windows as well. So what we're going to talk about is storage device design patterns. Maybe. Okay, so we'll do a brief overview of the pattern. I know George Russo's covered the pattern in his general pattern discussion. I'm going to touch on some of the things that he brought up previously and also go into a little bit more depth. Talk about an example. We'll go through the Windows.Storage namespace, cover AutoPlay scenarios, device configuration, and then have a summary. So this, you've already seen this slide yesterday, and like I mentioned, we're going to just go ahead and focus on the removable storage aspect of it. And this is primarily targeted at externally connected USB devices that represent themselves as storage volumes. So you can think of your thumb drive, cameras, digital video cameras that show up as mass storage, etc. A lot of the GPS devices also do this. So some specifics of this pattern. They're functionally represented as files and file folders in a file system. Windows can see them through Windows Explorer in the desktop or in the runtime in the new UI. The types of protocols that these devices use are USB mass storage class and also a media transfer protocol. MTP can show up as a volume in Explorer and can also be accessed via this Windows.Storage namespace. The transport we're focusing on here is USB, and the API that you would use to access these devices would be Windows.Storage. Some of the advantages of this type of using this pattern: if you have a low-cost device and you want to access it with a modern or a companion app, it's based on standard hardware that you can get off the shelves today. So it's fairly low cost from that perspective. It uses inbox class drivers, so it uses our mass storage class driver, and if it's MTP, it'll use the MTP class driver. It's supported in the Windows RT version of Windows 8. So no extra drivers are required to be loaded, etc. You just get a seamless experience there. And it supports AutoPlay. One of the disadvantages of this design pattern is that you don't have control over which apps actually access the device. You can indicate, we'll get into this in a little bit, but you can indicate the recommended or preferred apps, but you can't necessarily block other apps from talking to the device through the Windows.Storage namespace. So here's an example that we came up with just to represent this, where you have a digital camera, video camera, that stores its files in the flash memory. When the device is connected to Windows 8 for the first time, the companion app will launch and allows the user to import and edit the content. For example, apply filters and effects if that's part of your application design, or post the file directly to your favorite social media outlet, whether it be YouTube or Facebook, etc. No devices do this today, but we'd like to see more companion apps in the Windows Store that can actually talk to your devices. So the acquisition scenarios that we cover here are automatic acquisition, where you plug in the device. We go through the whole DSM process, and the application is actually found on the Windows Store and downloaded automatically. You've heard all about this. Or the user can navigate to the Windows Store directly and download it from there. So for device discovery, actually finding the device, the app would implement the device enumeration API and then pass that information over to the application, so the application can go using the Windows.Storage API and actually talk to the device. Or AutoPlay can pass the volume information over to the application, and then the application can go talk to the device. it gets passed as basically a folder to the application. And then device access, as we mentioned, is handled through Windows.storage. So the namespace is pretty simple. It's used to manage files, folders, and application settings. It's the standard way to access these devices with volumes in the Windows runtime. So if you're going to do anything with simple device access, this is the API you'd want to use. Here's a kind of a eye chart, but basically I wanted to cover the different interfaces that are included in the Windows.storage API. Common currency for this API is really a storage item, and this iStorage item is actually used to represent storage items. So it's files and folders, for example, the content on the device, and it will provide it can also provide information about the file or the folder. You'll primarily access or take advantage of the first 4 of these interfaces. The last one, I am not super familiar with the details of that particular interface, but it's not used commonly. So when we get into actually building support for Windows.storage and device access in your application, we start with adding declarations in the app manifest. So in order to support access to these devices, you'd want to declare support for the removable storage capability. You also want to do any file type association. So any file that you want to access on the device, any file type, you need to declare ahead of time in your manifest. And then also, certain situations you would also register as an AutoPlay handler in the manifest as an application. So let's jump into, like I said, the Windows.storage API is fairly simple. There's more detail on MSDN that covers this. And in the next hour, you'll go through a lab that Lisa Ong will walk you through that actually has details on, we have a sample, you'd go through the sample, you'd actually add support for, or update your app manifest, you would go through, tweak some settings in the actual application, and also take a look at the metadata that would live on the device. So for AutoPlay in Windows 8, there's a couple different ways you can approach it. The device can opt out completely. You could invoke some standard behavior where there's some standard behavior around general storage and also around a device with certain content type on it. For example, a DCIM folder on a camera or video camera, or even just a simple storage device. If you actually build the DCIM structure onto the device, we would see that as an imaging type device. You can also go in and recommend an app, or you can also provide custom events using autorun.inf. And we'll get into each of these in a little bit more detail here. So opting out of AutoPlay behavior. So this is something that's, the way we do it is new for Windows 8, at least from the device side. It's pretty useful if you have multiple volumes on a device and you don't want each of those volumes to pop up if they're not seen by Windows as a single device, piece of plastic. So you specify this behavior in the autorun.inf by just putting use AutoPlay equal to 0. So Windows will ignore this volume for AutoPlay and all subsequent AutoPlays. And also, one thing to note though is that if you do use this declaration, that any additional behavior defined in autorun.inf is disabled. So you've probably seen the standard AutoPlay behavior in Windows where once you connect a device, you'll get the toast popping up. And then once the user selects the toast, they're given options. And this is the standard, one of the standard AutoPlay workflows here. Initial device connection receives the AutoPlay toast, which we just saw. The list of handlers that can work or that are identified as handlers for that file type or that device type are provided in the flyout. You can either, the user can ignore the new choices moving forward if they select take no action, or when when subsequent AutoPlay handlers come online or new apps are downloaded that actually can handle those file types or those device types, those would provide a user prompt to allow them to select that new app if they want to. So some of the other things you can do are add recommended app behavior. So using the device metadata, you can provide a custom app name, or not a custom app name, but a recommended app name as you, the manufacturer, chooses. You can also add your own companion app as the recommended app. And then this would be the dialog that you get actually, and it displays the progress of the app download until it's completed. So custom event behavior is kind of cool because it allows you to define an event, put the custom event into the autorun.inf. You can see here where you say custom event and then event name. Then what you do in the manifest of your companion app is go and register as a handler for that event. Essentially, this is the closest way so that you can get to a vertical solution for standard mass storage devices. Now you run the risk of another application potentially identifying your auto run event and using it as well, but the likelihood of that, I don't know why somebody would go out there and find your AutoPlay event and kind of hijack it, but it's possible that they could do that. But if this is defined in your autorun.inf, then no other handlers are offered for your device. In Lisa's lab, hands-on lab, you'll go through how to actually create this custom event and how it works. So this is all coming down to configuring your devices in Windows 8. Our recommendation is to obviously define a companion app that build and define a companion app for your device to access. Define some recommended AutoPlay actions in your metadata, which, if you have your companion app, then you want to recommend that app as the app to use. If just a side note here, if there is no metadata provided, then we fall back to the AutoPlay behavior, the standard AutoPlay behavior for devices and volumes. And then you'd want to register your device itself for AutoPlay. The device registration process is the same as it was in Windows 7. And then for desktop applications, so non-modern applications, registration is exactly the same as in Windows 7. So if you're supporting multiple platforms and you already have an investment in device stage, this is handled in the way we implemented it in Windows 8. Device stage experiences will continue to function in Windows 8. The same metadata package can be used for both Windows 7 and Windows 8. I believe you've probably covered that already. The metadata would allow both a device app recommendation and a device stage experience, but there is precedence over device companion app over the device stage experience, and also AutoPlay over device stage. So in summary, supporting this pattern is fairly straightforward. It applies to mass storage devices. The devices have class drivers built into Windows. It's a simple API for device access through the Windows runtime, and we designed it to be as simple as possible. You can create a vastly improved end user experience for your consumers and customers. Use device metadata to decorate so that you have better AutoPlay experiences and recommended applications, etc., richer information about your device. Develop companion apps to really expose the additional functionality or some upsell opportunities. I know we've talked about that in the last day. and then include support for AutoPlay. We believe that that's one of the best ways to get users into your applications and doing the things you want them to do with it. So there's a couple pages of resources here. How to declare app compatibility in your manifest. We talk about contracts and extensions. Registering an app for AutoPlay is covered on MSDN. Device metadata portal, where you'd submit all your metadata. And Windows.storage namespace is covered in detail on MSDN as well. Next up, in about 15 minutes, we'll start off a hands-on lab for mass storage device apps. There's a mass storage sample out there on MSDN. It covers multiple languages, and it's fairly straightforward, easy to consume. And in order to identify your device and actually start using it, you would use the device enumeration and activation API, which is also defined. And there are samples available on MSDN for that. I went through this content fairly quickly, but we have Ken Hardy and myself up here to answer some questions. We also have Lisa Ong in the back, who actually helped develop the API itself, if you want to ask any follow-up questions. Like I said, it's a simple pattern. There's no reason to spend more time talking about it until we get into the actual details, or if you have specific questions. So Ken, would you like to come up here and help me field some questions if there are any? Yes, sir.
Okay, first question. Is Windows 8 support multiple partition on removable device? Windows 7 not.
Multiple partitions. So does Windows 8 support multiple partitions on a removable device? And
so in flash drive, Windows 7 doesn't support multiple partition. Question.
Good question. I do not know the answer. Does anyone? Peter?
I don't believe Windows 8 supports it either.
Excuse me?
Windows 8 doesn't support it either.
Okay. In this case, second question. Is it Windows 8 RT ARM? I don't know talking about x86 because I tried already. Support multiple LANs on the same removable device. So if I have a SCSI interface for flash drive, my device support two LANs for different compartments on flash drive. Is it supported on Windows RT?
I see if Peter understands or knows the question there, the answer.
I'm not sure. Does Windows 8 non-RT support? I don't know if we support multiple ones on USB storage devices.
But Windows on x86 it's supported.
Okay. If that's supported on x86, then I would suspect it's supported on ARM, on Windows RT, but I can't say for sure.
We'd have to actually.
10 years out of Windows storage.
We'd have to take that question down. We're not, I'm not specifically on the storage team, but we did create the API for you to talk to it.
Okay.
Okay. Yes, sir.
Does this relate to auto run on CD at all?
So the question was, does this relate to auto run on CDs?
AutoPlay and AutoRun share the same system. AutoPlay kind of evolved out of AutoRun, so it is related. That AutoRun.inf file we talked about, that's kind of the file that configures AutoRun if you had a CD-ROM or just another volume. We also are now leveraging that for this storage as a device scenario.
So is there anything in Windows 8 that does like running applications on the CD? Or would that be handled on the desktop side?
It's pretty much the same as it's been in the past. As you know, it's been locked down quite a bit for security reasons. Lots of little passengers have come in on that channel, and so we've kind of closed up a lot. But basically, we've taken what you would have seen in Windows 7 in a dialog box, and we've put it into that AutoPlay flyout that you saw. So if you have a scenario for auto run, it will pretty much work the same as it did in the past. It will just look like the new UI.
Would it launch the desktop applications then?
Yes, AutoPlay can launch desktop or modern applications the same way. It will transition you if you're in one to the other. That's true of everything. So if you build for any kind of device, if any of you are working on devices other than storage, it's the same way. You can register either kind of application for AutoPlay, and AutoPlay will let the user choose, and it will automatically transition to the right place.
Any other yes, sir.
Can this be used with network attached storage NAS boxes?
Can this be used with network attached storages, NAS?
So AutoPlay kind of operates out of the file systems for drives, for storage. So once those look like drives, they will appear in AutoPlay, and we will look at them once they kind of come into the system, and we'll run AutoPlay on them like anything else. But if you're just accessing them through IP or whatever, then you're not gonna, AutoPlay won't fire for that.
Any other questions?